சார் நீங்க வளமுதர் சார்.
எஸ் சார், எஸ் சார்.
நீங்க பண்ணிட்டீங்களா?
ஓகே சார்.
So I take the opportunity to welcome our keynote speaker, Dr. Iranian, Professor and Head, Savita University. I welcome all the delegates for the COMAT 2023 afternoon session for the invited talk. I now invite Dr. Walchand to introduce our invited speaker.
Okay, sir. Thank you, sir. Dr. D. Iranian, Professor and Head, Department of Mathematics, Savita School of Engineering, Chennai, India. Completed his PhD in the field of computational fluid dynamics in Anna University, Chennai. Having more than 26 years teaching experience in various reputed engineering colleges in Chennai, guiding 3 research scholars at present, having published around 25 papers in international journals and published 1 textbook also. He is a reviewer in many international journals. He is life member of various professional bodies. Thank you, sir. Very warm welcome to our new reign, sir. Please take
yes, sir. Yes,
please
sir.
take this session, sir.
Okay. Am I audible, sir?
Yes, sir.
Yes, sir.
Oh, okay. So, first of all, thank you for giving this good opportunity. So, I'm sharing my screen. So, I'm Iranian. I'm working as a professor in Department of Mathematics in Savita School of Engineering. According to my topic, the crucial role of mathematics in fluid flow, I want to deliver some concepts about this fluid dynamics actually. So, I will start now. Why I am choosing this topic, crucial role of mathematics in fluid flow. What is fluid flow, first of all? Actually, wherever it is something moving in air, water, whatever it may be, we are walking, whatever it may be, there will be a moving. So, if it is there moving, automatically flow will be there. Flow is, before that, computational fluid dynamics is concerned with obtaining many numerical solutions and solving governing equations of fluid flows. So what do you mean by fluid flow? Wherever it is either water or smoke, or I will give some other examples. Wherever it is, that is, we have flow. Here, actually, this topic is belonging into mechanical people. Mechanical only, wherever that is engines, bike engines or car engines, aeroplane, train, wherever it is. Okay, so there will be a fluid. That kind of mechanical people they are using actually. But what about what is mathematics role in this computational fluid dynamics? Many theory problems are there, but how we can solve that problem? All the theory problems we cannot solve, but by mathematics only we can solve. So a big role in this computational fluid dynamics. Okay. So in this name itself, computational. So automatically mathematics is appearing there. Okay. So this is that first one, fluid problem. How it happens here? This is actually the physics, mathematics, everything. Physics almost mathematics. Okay, both are the same. Here we have to form the problem. This is a highlight of the problem. That only I am first telling here. This is the whatever the problem in fluid dynamics that must be formed by Navier-Stokes equations. And that navigations which occurs, so many concepts are there. I will explain below. Um, by using some numerical methods, analytical methods, many methods are there. So, okay. And then that applying, where we are applying that methods now, using that computer programs like MATLAB, something. Okay. And then after getting the results, that result only we can show by the graphs. So it is actually a big role in computational fluid dynamics along with the computers. That's all. So computer software, many softwares are there that one we have tried. Okay. So here it is a field of science and engineering that describes the flow of fluids. This is a good example. This diagram you can see there that a bike is a man is riding a bike, okay, opposed to the some winds flow. So from that bike silencer, um, fuel is changed as wind only. It's okay, but this a smoke will be there. How it comes from by flow only. Okay, wherever is that moving, it is flow. Okay, there are some different types of fluids. Or what are the fluids here? Liquids, gases, and plasma. Liquids, water, honey, and then air, mercury, something here. Okay, so air also there will be a flow. When an aeroplane is moving on the air, okay, how it forms, how it flies. That means what? The flow of the air, it comes outside through the turbines, automatically it will flow. Like a ship, everything is there. So, okay. So, and then liquids, gases, and plasma. What do you mean by plasma? Means it is our in our blood vessels in that we have a plasmas. So that also our in our blood veins, um, blood is moving along with some different fats, something. Okay, so there also fluid is there. Okay, so these are all good examples for that one. Next one, these are all some types of fluid flow: steady flow and unsteady flow. There are some pairs of flows. It is given here: steady flow and unsteady flow. So, what is steady? What is unsteady? Basically, one-dimensional heat equations, two-dimensional heat equations, some equations are there, partial differential equations. So in that one, steady, if it occurs time in that steady equations means that is called unsteady. And steady means no any time. And then laminar and turbulence flow. Laminar flow, I will show some examples after this slide. Laminar and turbulence flow. Next, uniform and non-uniform flow, rotational and irrotational flow, one-dimensional, one or a two-dimensional or three-dimensional flow. Next, compressible and incompressible. Okay, all flows are not incompressible as well as not compressible. Okay, so for that we have some examples. Now, you can see there that first diagram. In this one, we have a flow. You can we can imagine some rivers or some other dams like that. Suppose rivers means there will be some bridges. Under the bridges, we have some pillars. So through that pillars, it will not go. So aside that pillars, the water will flow here. So based on that volume of that pillars, it will divert like this. And then here itself, it is narrow, very narrow. So no saturation is here, but in this one, some saturated flow is there here. And then based on this width of the pillars and the volume of the pillars, it will change here. And so these are all some different flows. And this one is, if you have some liquids, if you drop in water, so something will change here like this. So some colored liquid, if you drop in that water, it will happen like this. Okay, we can see this kind of flows in smoke. Somebody will smoke at the time that the smoke will fly. Okay, that lights. Okay, so this kind of so many flows are there here. So these are all some good examples for that in different situation. And the next one, you can see here, this is a below one. There are two pipes are there. One pipe is without any disturbance, it is flowing here. So no any disturbance means no very less pressure. Okay, no any density like that, no any pressure here. But in this one, some bend is there. That means what? That the water flow through this pipe is disturbed. So is disturbed means automatically that the pressure will something increase. So the force will also increase here. So it looks like this water flow. Okay. So here itself we can say that the flow is something laminar flow and another one is turbulent flow. Like this in any one tube, if you press that, if you are giving water for some plants through the tube, okay, without any disturbing, it will flow automatically. Suppose on the tip of that tube, if you press that, automatically water will flow, that the flow will be increased. That means the force will be increased. So like that. So at the time that laminar flow automatically changed to turbulent flow, like that. So it is the good example for laminar and turbulent flows. And this first topic, that means in this slide, in this diagram, this is actually three dimensions, three dimensions diagram here. In this one, through this pipe, here something disturbance is there, so automatically it is something rotation here and it will again getting flow outside. So okay, so this in this situation we can say this is a rotational flow plumb something. So without any disturbance it is going now, that is laminar flow, and some other calculations are there. Okay, that is now needed here now itself. So with the disturbance means automatically it is pressing and force will be increased, so automatically it is a turbulent. So laminar flow, turbulent flow it is given, and these are also some funny slides. Here, when our wind in our climate pressure is very low, what will happen? Automatically, so many this kind of accidents. Here, this roof will getting top. Okay, this one, and then umbrella. It is it comes actually opposite side. So because of low pressure means automatically the wind will be very fast. So the force will increase here. So okay, in during rainy season, we are seeing in the news itself, it is a low pressure is formed at the time. Very wind and rainy season are there. So these are all good examples. So because of that, the pressure, the flow is something changed here. Next, one more please on here. This is an aeroplane. It flies. How it flies? It pulls the air, throws. Actually, it pulls outside in backside from front side through the turbines. So here the turbines are there here. So through the turbines, it pulls airs outside here. So okay, so because of that one, it flies opposite side. I mean forward. Okay, so ships like that. This also we are going, and buses, everything, any vehicle, it is going on there. Okay, so here outside that engines, outside that mediums, it is flow is happening here. Inside that medium, I mean, suppose for example, bikes or cars or some or any vehicle, some turbines are there, some petrol is changed into some, that means fuel energy changed into say, this kind of energy. So there also we have some fluid flow. Okay. So many fluid flows are there like that, and this is also one good example. Here in this one, it is also something water or some other very tiny liquids are there here. And this one, we imagine that this is honey. So you can the same portion spoon, that the spoons are in the same position, but the flow of that fluids, how it happens. In that first one, it is flowing fastly and it drops in the floor. But it is here, second one, it is very slowly it is dropped, like honey and then we can say that castor oil and engine oils. Okay, these are all dropping very slowly. Why it is happening? In this one, this castor oil, honey, viscosity is very high. But in this ordinary water, viscosity is very low. So here high, that's why it is happening here. So okay. And then another one, yes, previously I told that in blood, in our blood vessels, blood is flowing like say, like that. It is uh, it is actually vein, blood veins. It is going to heart. Listen, healthy artery. Why it is healthy artery? That the flow is very comfortable. It is moving. But here, somewhat some fats or some other I don't know any medical technical terms. Some terms are there here. Adina. It is restricting that fluid flow of the bloods, and it is totally collapsed. Actually, here actually fully blocked. So it is actually called a block. We are having that. So not we are having that. Some people, some hot disease people, they are having like this. So here, what is happening here? Here in first diagram, flow is freely moving, but in the second one, it is struggling something. But in this one, the last diagram, we have fully fat. Fully fat means viscosity that is very high. So the movement of that flow, I mean fluid, it will not move. So at the time, the heart attacks, something cardiac arrest, it is happening here. So here also in our blood vessels also we are having fluid flow. So our blood is fluid compared to water. In our blood, viscosity is high. Okay. So, so from this, what we are concluding that actually, um, because of many reasons, what are that? Pressure, viscosity, and then velocity, and then volume. Okay, and then dams. You are seeing that dams in that water reservoirs are there. So, okay, so that itself volume. Volume is also very important, and also mainly dimensions. Dimensions is very important. Okay, so one dimensional or two dimensional or three dimensional. Okay, so the dimensions. So in that water reservoir, wherever it is, and then dimensions here, viscosity, pressure, everything is important parameters in that fluid flow. Okay, next one. Okay. So here, not only one parameter in that fluid flow, so many parameters in that fluid flow. So based on that different parameters and the different situations, the problem will be varied. So that kind of problems we have to solve. Before that, this one, some different kinds of fluids. Basically, we can classify into two types. Number one, Newtonian fluids, and another one is non-Newtonian fluids. Newtonian, that mathematician is having this name fluids. Okay. So for this one, every we are having basically the in the fluid, suppose viscosity is constant. Constant means no variable, it is fixed. That kind of fluids is called a non-Newtonian, and it is something very very okay. So it is called a non-Newtonian fluids. So in that one, what are our examples for the Newtonian fluids and non-Newtonian fluids? In example, for non-Newtonian fluids, water and air. In water, viscosity is constant, no change at all, unless it is disturbed. And similarly, here, salts, materials, polymer materials, blood, toothpaste, paint, something. These are all. In this one, the viscosity is something different. It is actually called a variable. So this kind of flows are called non-Newtonian fluids. Okay. So, right. Now, in fluid flows, many occurrences are there. That means many parameters, many situations, many coordinatal geometries. What are the coordinatal geometries? No? It may be that the dimensions. Suppose under the bridge, pillar is there. Pillar is actually it is called a cylindrical form. So that cylindrical form means that is a three-dimensional flows. Okay, some tubes are there. In that the tubes, through the tubes, the water is flowing. That is one-dimensional. So in one direction only it is going like that. And then suppose any one plate or any one vertical plate or horizontal plate is called, these are all called two-dimensional coordinate geometries. Okay. And then some other situations are also there. In our homes, we are having some or a tea filter. We know that the tea filters. Okay. So what is the tea filter? Is there any fluid or any concept is there? No? Yes. Through the tea filter, that tea actually the flow is there. Through that one it goes. But what is that medium? That medium is called porous medium. Okay, so that is dots, single dots. So many, my tiny dots are there. That are all. That is actually medium. Through that medium, the flow enters and exits. So that kind of medium is called porous medium. So like this, so many mediums are there, or some other stretching sheets, or inclined plates. Okay, and then roadside some ditches are there. That is called actually square cavity. Okay, so these are all so many mediums. Okay, so now we are building one problem. For example, okay, so flow is some different kinds of flows. It may be water or air or honey or mercury, whatever it may be. Okay, some fluids are passing through some medium. Okay. At the time, outside the temperature, inside the fluid temperature, inside the medium temperature, and then pressure, and then velocity. Okay. So many parameters applying in that situation. Okay. So all this kind of situation in one problem, how we can solve? By orally we cannot solve it, and mechanically also we cannot solve it. How we can solve? So by mathematical form only we can solve it. Okay, so how we can write that? So that any theory problem on that fluid flows, we are converting into mathematical terms. How we can mathematical terms? That is called actually natural. Sorry, so many conversions are there. That means Navier-Stokes equations. Before that Navier-Stokes equations, and to solve the Navier-Stokes equations, we have to see this kind of activities. That means to solve the problems in fluid dynamics, physical properties of fluids such as velocity, pressure, dimensions, temperature, everything. So, okay. So many practical applications of fluid dynamics, including the calculation of forces. Force also one of the important parameters. Okay. So how we can solve that? Okay. Next slide. So in this slide, I am telling about the physical parameters, whatever it may be, that is given here. And then here, applications of fluids, where we are applying pure sciences, astronomy, astrometry, atmospheric. Okay, so in our every city we are having some meteorology department. Meteorology department, what they are doing, they are predicting that weather condition. How they are predicting the weather condition, moving of clouds. How it moves, very fastly or slowly, or very height also, in low level or higher level. So there are also fluid flow. Therefore, in the meteorology department also, it is very useful, very much useful. Oceanographic, geophysics, astrophysics, biological sciences. Previously, I told some examples. Biological sciences, combustion engines. I mean, mechanical terms here, and then turbojet and the rocket engines. So in this all this field, not only I am giving here very minimum number of fields. So many fields are there. In that one, fluid flow is very much useful here. And then, okay, next slide. In this one, this fluid dynamics. Okay, what we are going to find? So fluid is we are passing. It is exiting. That side enter. This is entering. That side is exiting. In this one, what we have to do? Okay, pressure is there, volume is there, temperature is there. What actually we have to find out? So when it is passing through fluid passing through some mediums, what is happening? Mainly this heat transfer. Okay, when we are boiling some water in a vessel through heat, the temperature is changing. Okay, so temperature is changing. Some heat particles below that side. Heat particles, it gets heat means automatically it will be weightless. So it comes outside. So you can see that some bubbles are coming upper side. That means what? Light weighted particles. So heat transfer is changing there. Okay. So it is the discipline of thermal engineering that concerns exchange of thermal energy from one physical system to another. Okay. Similarly, heat transfer only occurs because of temperature difference. I told temperature difference means light vehicle particles when it get water particles getting lightweighted when we are heating, so automatically it comes outside. So weighted particle it comes downside. So through this cycle only, full of water is heating and then it is boiling like that. So where the temperature is occurring, there will be flow. Okay, and then heat transfer is classified into different kinds of mechanisms. What are the mechanisms? One is conduction, another one is convection, another one is thermal radiation. Okay. So next slide, I'm explaining this. This is on a vessel is on the stove. It is heating now. Okay, what is happening here? There are three kinds of uh, happenings we are having here. What is that? First one, conduction. What in by conduction? Heat transfer into your hands as you hold a hot cup of coffee. Suppose you are holding a hot cup of coffee, our fingers will get a heat. That is actually conduction. Okay, and then convection. Heat transfers as barista steams cold milk to make a hot cocoa. So convection means particle by particle. It is that means heat temperature is moving on that vessels. Suppose we are heating or heating water on the vessel in the vessels means that means immediately it will not get some heat. So through some time, it will take some time. So that on the vessels of that particles of that vessel, one by one, it is getting heating. That is actually called a convection. And then radiation. Reheating a cold cup of coffee in a microwave oven. Reheating, it emits. Radiation means actually it is a emits. Like what is the place? Tirutani, Velu, these and all places, so many temperature is there in summer. Why? Because of emitting, that means the radiation of heat because of rocks. Many rocks are there in Vellore and the Tirupani. That's why heat emitting is there. It means radiation. So these three kinds of temperature changing is occurring in fluid flow. Okay, main thing this one. And another one is mass transfer. It also one important role. What do you mean by mass transfer? Means temperature is happening, particles are moving by using heat. So heat transfer is happening on the fluids. Mass transfer. Suppose some density is there in the fluid. Uh, when we are heating, it will not heat immediately. It will take some time because of the density of the fluid. So there itself, some mass transfer is happening very slowly here. Okay. For that, we are having some. It is the transport of one or more components of a mixture, a fluid or a solid material within a phase of or the phase boundary. Mass bound transport within a phase of to that phase of is called mass transfer. One phase to another phase, it is moving. That is called a mass transferring. Right. Okay. So previously I told that so many situations are there when there is a fluid flow, all that concepts, all that messages we have to apply on that fluid flow. What will happen? How we can solve the problem? Okay. So if this kind of fluid is I am applying here. How much fluid I have to get? How much temperature is there? How much velocity is there? All the items. For example, uh, in ISRO they are launching a rocket means okay. If you are keeping vertically, it is going through the space. That is not only one part. So many items are there, so many parts are there, so many concepts are there. Like that, in this also, we have so many parameters. So all the parameters we have to conclude in a mathematical form. That mathematical form, how it appears, that is called actually Navier-Stokes equations. Okay, Navier-Stokes equations are nothing but partial differential equations only. Not only simple partial differential equations, it must be actually non-linear coupled partial differential equations. Okay, all the items previously told so many parameters, all the parameters we can apply in the Navier-Stokes equations. After building the equations, that equations are called governing equations because that equations only governing the nature of the problems. Okay, so like this in next slide I'm going there. Okay, these are all already I told that velocity, pressure, temperature, all those things. So everything we are applying in the Navier-Stokes equations. Okay, so here how many Navier-Stokes equations are there? So generally, we can take four kinds of Navier-Stokes equations, right? So what are the names? First equation is equation of continuity. This equation of continuity becomes one-dimensional or it represents dimensionals. Two-dimensional equations or three-dimensional equations like that. So, okay. So this is the example for dou v by dou x plus dou v by dou y equal to 0. This is actually two-dimensional equation. Okay, so we are considering two-dimensional geometry. Okay, so this is a continuity equation. Next, equation of momentum. Momentum means what? Uh, there is some momentum means there should be some velocity, there should be some movement, everything is there. It should be there. So this is called a momentum equation. In this momentum equation, convection, temperature variations is there, it should be there, and then mass force, surface force, viscosity. So we are applying here viscosity here, surface that is area level, how much, and then mass. Okay, everything is we are applying here. So this momentum equation, in this equation, this first term represents momentum convection, and then second term represents mass force, third term represents surface force, and this totally fourth term represents viscous force. Okay, so these are two equations, and the third one is equation of energy. Equation of energy. In that, in this equation, we are calculating from this equation we are calculating velocity, and in this equation of energy, what we have to find out here, temperature we have to find out from energy, heat energy, where it occurs now in that temperature difference only. Okay, therefore this is called equation of energy. From this one we are calculating temperature. So here also for everything we have something dou h by dou t. It is actually called what? Local change with time. T represents time, and this is a convection time. And the third one is pressure work. Fourth one is heat flux, and the fifth one is heat dissipation term. So many terms are there here. And then next one, equation of mass. This is actually it. This equation involves that mass transfer. Uh, in that mass, what are the parameters we are having here? Density, velocity, and a gradient operator. Okay. Right. So these are all basically I am giving here these four equations for Navier-Stokes equations, and also called what is it? Governing equations. Okay, right. So here Navier-Stokes equations have a nonlinear structure with various complexities. Yes, and thus it is hardly possible to conduct an exact solution for those equations. Consequently, different assumptions are required to bring the equations to a possible solution. Okay. So again, the same thing only. So many applications are there, so many terms are there, everything. How we can solve this kind of applications? Okay. Listen, actually, these four equations of simply I'm giving here, but there's so many operators we have to apply here because of the nature of the problem. Okay, and then right, this is one paper. In that paper, from that paper, actually, it is my paper only. In this paper, I'm giving this one as example. This is a continuity equation, and this is a momentum equation, and this one is third one is temperature equation, energy equation. Fourth one is concentration equation or mass equation, right? So here that third term, from the second equation. This one is representing the name of the fluid. What kind of fluid is given here? So based on that fluid, so many fluids are there. Natural fluid, forced convection, natural convection, okay. And then some fluids are there. What are the fluids? Now itself, so many fluids are there: ferrofluid, Maxwell fluid, and Castaneous fluid. So many fluids are there. So in what fluid we are considering for our problem? Okay, that one we have to implement it here in this equation, in this momentum equation we have to apply. Okay, so now these equations are called what? Governing equations, and it looks like what? Non-linear coupled equation, coupled partial differential equations. Okay, for these four kinds of equations we have to give a solution. How we can give? For that, along with here some boundary conditions are there. U equal to 0, U and V are some velocities, T is some temperature, C is some concentration. Okay, up to Y equal to 0, like this. So initial temperature is velocities are 0, temperature, this is a wall temperature, and outside the wall temperature, like this. So these boundary conditions and initial conditions also we have to apply. When we are going to partial differential equations, this kind of applications of partial differential equations, there must be that boundary conditions and initial conditions. Okay, without that initial and boundary conditions, we can't solve here. So it should be given here. Okay, and these are all given as steady state problem. Okay, why it is called steady state means dou u by dou x, but it is not appearing dou u by dou t. That means what? We are not considering about the time. So time is not occurring there, no? That is called what? Steady state only. Time is occurring now, automatically it is changing. Time is changing, so the temperature is also changing or mass also changing. So that is called unsteady. Okay, as you know that, I'm telling this one. So this is a steady state problem actually. This is another one example I'm giving that. Okay, this one. This is actually 3 dimensions. 3 dimensions problem in this one. Okay, and in this every equation, first term we can see here, dou rho by dou t, dou rho u by dou t. With respect to t, we are differentiating. So here t occurs. That means what? This is a 3-dimensional unsteady state problem. Okay, so how we can solve this kind of problems? These equations store, and not only this is basic equation terms are given, but the different parameters if you apply now, the number of terms will increase in these equations. How we can solve? Okay, that itself only mathematics roles as a king here. And okay, how it solves now? Directly we cannot solve. So how we can solve? Using some, these are all actually called dimensional equations, dimensional terms. So we have to solve the equations by using some non-dimensional parameters. Non-dimensional parameters, that are all what? These are all Prandtl number, Nusselt number, Sherwood number, and the skin friction. These are all, every term is there here. Everyone is non-dimensional parameters. All these non-dimensional parameters, if we are applying in the equations, that the equations transform into dimensional equations. Okay, so that the dimensional equations, we can solve this. We can solve the dimensional equations directly. That means partial differential equations we can solve directly, or the partial differential equations we can convert into ODE. That means ordinary differential equations. that itself also we can solve it. Okay. So these are all some non-dimensional numbers, Prandtl number, and this is a Grashof number. For everyone, we have some individual properties. Okay, but because of no time, I'm telling this. These are all important terms. And third one is Smith number. Okay, these are all some non-dimensional parameters. Okay, how we can solve that kind of equations, how we can apply. Okay, previously I told, after using the non-dimensional parameters in partial differential equations, that the equations transformed to non-dimensional. Okay, non-dimensional parameter, non-dimensional partial differential equations. Okay, non-dimensional parameter equations we have to solve. How we can solve? For that we have so many methods nowadays. Okay, very old method. That one is called a finite difference method. That also I can mention here. Yes, right. These terms are important. The solution of the Navier-Stokes equations can be realized with either analytical or numerical methods. Okay. So in two kinds of methods we can solve this. One is by analytical, another is by numerical. Analytical method for all the problems we cannot use. For some such kind of some problems we can use that. But a numerical methods as usual, we can. This is very powerful method. In this numerical method, so many methods are there. Generally, it is numerical method. So that methods, if you apply, we can get some exact answers. So okay, so it is why it is given here. The analytical method only compensates solutions in which nonlinear and complex structures in the Navier-Stokes equations are ignored with several assumptions. Okay, so we made assumptions, but without the assumptions we are solving, then why it is we are using analytical method. So okay, so it is not powerful method actually, but in that numerical methods very easily we can solve it. Okay, how we can solve? So many methods, Rangikuta method, shooting method, so many methods are there. Okay, how we can solve? Next one I am telling that. These are all numerical approaches. Right? How we can solve that kind of equations? Finite difference method. This is old one, but it is very exact answers you will get here. And a finite element method, that also very powerful method. And a finite volume method, shooting method. Okay, so many methods are there, right? For we are applying these methods on the problem. After that, how we can get that solutions? How we can express the solutions through graphs? Okay, for that we are having so many softwares there. What are that? Laplace transform, and then softwares means MATLAB, and then now itself Mathematica. Okay, these are all softwares. CAD, MathCAD. Okay, these are all softwares we can use. Okay, to get the solutions by using these methods for the given kind of fluid problems. Okay, so. These are all actually belonging to mechanical oriented problem, not only mechanical, chemical also. Okay, and civil service. Okay, not civil service, civil department people, they are doing so many papers. Okay, so in that one, so civil, mechanical, and chemical, all the problems from the parts we can solve easily, not orally, solve by what is it, mathematical only. So, okay, so many practical problems are solved by mathematical modeling. Okay, so mathematics is very powerful tool when we are solving any theoretical problem. For every problem, we have some solution using this. So I told about some mathematics role on fluid flow. Not only fluid flow, in so many fluid flow, so many fields, mathematics appearing. I'm choosing here fluid flow. That's all today. So mathematics is very big tool, very important and essential tool for solving this kind of problems in fluid flow. Okay. So this and all I want to deliver. Um, so Thank you.
Sir, very nice presentation, sir.
Yes, sir.
You have given lot of numerical techniques are given, sir. Thank you, sir.
Yes, sir. Yes,
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 sir.
sir.
Yes, sir. Lot of analytical methods also there, sir. Same problem.
Yes, analytical method is also there, but not all the conditions we can satisfy.
Yes, sir. Homotopy analysis method, homotopy
Yes.
perturbation method, various nitration method,
Yes, yes.
modified various nitration method,
Uh,
Fourier transform method, lot of methods, sir.
yes, yes, sir.
Yes, sir.
But I don't have the time to tell all the
Yes, sir.
methods.
Yes, sir. Yes, sir.
So very shortly, I am telling you.
Yes, sir. Numerical,
So,
another numerical approaches also there, sir. Kalarkin method, Heller box method. Like
yes, yes. So many methods are there.
yes, sir.
One or two examples I told you.
Yes, sir.
Because you gave some, within the time I have to complete, that's why I prepared this route.
Yes, sir. Mathematica, we got a good solution, sir. For
Yes, yes.
Mathematica.
Mathematica is good tool.
Yes,
Yes,
sir.
sir.
Very nice tool, sir.
Yes,
Zeroth
sir.
deformation, all deformation we will get. Good.
Yes.
Audience,
Yes.
any questions from
Uh,
audience?
Yes, sir. This is Anand. Shall I ask one question, sir?
yes, sir.
Yes, sir. Yes, sir. Hello, sir. It was actually a very nice presentation with all the mathematical aspects covered about the fluid mechanics. So, just I want to ask you, sir,
Yes,
can
sir.
we apply any machine learning on this mathematical aspects where we can keep all the properties like temperature, velocity, dimensity as a feature? Those can
Hmm.
be evaluated using the mathematical functions. Those are built in the machine learning model. So can we do like that? Anything that will help something for the
Ah,
automation?
oh, okay, okay. So we can try first of all. Nowadays, this fluid is applying in the fuzzy, oriented fuzzy, something they are doing, one or two people. Okay, but your machine learning, okay, we will try. Okay, if
Yes,
you have any idea, we can share it and do it. Thank you.
yes, sir. Yes, sir. Definitely. Thank you, sir.
Yes, sir. Any other questions?
Any other questions from audience?
Okay,
Audience,
if
any
it
other questions?
means
Yes, sir. Yes.
so, if there is no any question, means
Yes.
Sir,
I can.
thank you. Thank you for your excellent presentation. This covers mechanical engineering and part of science also. It was really
Yes, sir.
interesting, sir. It was interesting to integrate mathematics with kinetics and all that. Thank you very much, sir. Thank you very much.
Thank you, sir.
And
Thank you for
joining us
giving.
and honoring us.
Yes, sir. Thank you for giving this good opportunity. Your coordinators of this conference, to all of them, I once again thank you, sir.
Thank you, sir. Thank you very much.
Yes, sir.
Wish you a happy
Thank
new
you,
year,
sir.
sir. Thank you, sir.
Thank you, sir. This is the same. Thank you.
Thank you, sir.
Okay.
Professor Balamuralidharan,
Yes, sir. Yes, sir.
is the session chair available for?
Yes, sir. Anand sir is there, sir. Anand
Okay,
sir.
okay.
Sir, welcome, sir. Anand sir. Welcome, sir.
Yes, sir. Thank you so much. Yes, sir.
Yeah,
Thank you, sir.
session
Welcome, sir.
chair, Dr. Anand, hearty welcome to chair the
Yes.
session. Sir, you can proceed, Professor Balamuralidharan.
Yes, sir. Sir. Another one person also there, sir.
Co-chair, huh?
Co-chair, Madam Jyoti, Madam joined, but right now not there. Okay. Is there any? Okay. Tell me. Okay. Is there any not presented people are there? Not presented authors?
Those
Please,
who missed their
missing.
presentation in the
Yes.
last 5 sessions can also present here, both
Yes.
computer science and mathematics. If anyone is here, please either raise your hand or tell us, or you can even
Yes, sir.
put your abstract number and say that you are ready, so that we can
Hello,
call you.
sir.
Yes.
Yes.
Can I present?
Yes,
You are,
yes, yes.
tell your abstract number, madam.
Abstract number, please put it in a chat box.
Put it in the chat
114,
box.
sir.
Okay, 114. Okay. Okay, madam, you can start, madam.
Okay.
Any other are there? Kindly put your abstract number in chat box, please. Message box, please put it. One not one Bharati. Bharati madam, next you can present madam. One not one next. Okay. Any other are there? Kindly put it in chat box. Your abstract number only, please put it.
Hello.
Yes, yes, proceed. Yes, proceed. I think you can keep your mobile in the horizontal manner, auto rotate.
Yes.
Yeah.
Is the screen is visible?
Yeah, visible. You adjust the content.
So good afternoon, everybody. This is Said Ali Fatima. I am studying computer science at Valyamal College, Chennai. So here's our research paper, which is about predicting the customer satisfaction using machine learning. Um, so we are in the era which has a tremendous growth in e-commerce. Growth on online stores is remarkable. So is the customer behavior and customer satisfaction. Many prominent brands have their own factory outlet stores, and to sustain in this competitive era is still more challenging for the brands. The growth of any business is customer centered, and it's more important to retain the customers for its growth. So our paper is basically intended to study the customer satisfaction of the store Zudio, which is a shop from Chennai, which deals with a wide range of fashion and lifestyle products, um, which has established its own brand. So we have used two basic machine learning algorithms, which are random forest and cluster analysis, to analyze this data. The results we have found are very interesting. Let's get into this. Uh, so, for any business to sustain, customer satisfaction is the prime factor. Social media plays a pivotal role in modern advertising. Due to its extensive reach and diverse user base and engagement potential. Some key aspects are vast audience reach, targeted advertising, engagement and interaction with the customers, visual approach, analytics and insights, influencer marketing, which is commonly called as paid partnership, customer feedback and insights, cost effective advertising, brand building and awareness, adaptability and innovation. So these are these algorithms which are predicting customer satisfaction. But we use random and cluster analysis. We basically did a survey in which we prepared 24 questions, in which more than 150 people were participated, and their responses are collected through a Google form. This survey covered both genders that comprises of various categories such as students, government employees, businessmen, and homemakers with a monthly income ranging from 10K to 2 lakhs. Purchase frequency. influence of celebrity endorsement towards the brand, purchasing experience, reasons to choose the store, sales service, customer satisfaction, recommendations to the friends, and rating of the store were overall analyzed and recorded. Data cleaning was basically not required for us as no data was missing, and the data collected to the full form was stored. For such data, we have used two methods, which is random forest and analysis. So, random forest is an algorithm which is popular ensemble learning method, which is used in machine learning for both classification and regression tasks. For customer satisfaction prediction, random forest can utilize various customer related features such as demographics, purchase history, website interaction, customer service score, etc. By analyzing these features, it predicts whether a customer is likely to be satisfied or dissatisfied. The next technique we have used was the clustering technique. Clustering rules on the quality data. Clustering relies on the quality of the data. It we If we have to use the clustering technique, the data has to be clean, relevant, comprehensive, which is essential for the accurate segmentations. It provides a valuable framework for the understanding with the customer behavior, preferences, and satisfaction levels. By identifying the distinct customer segments, businesses can tailor their strategies, products, and services to meet the specific needs of the different groups. So we have done basically two analysis. First, for the random forest method, random forest algorithm was used to predict the customer behavior with the parameters such as age, income, product, brand quality, customer shopping experience at the stores, malls, and so on. And next is the customer satisfaction, which is measured with the question number, which is in the questionnaire. The questions were included the sales service, affordable price with wide range of size, recommendation of the recommended by the friends or not, and the rating of the store, etc. So these were basically used as the internal node of the random forest algorithm with multiple trees, and aggregation was done to measure the regression. So this is the formula we have used to find the final G. This is the formula.
Your voice is breaking, madam.
Not audible.
I think she has left.
Achha, okay.
Okay, sir.
Yeah.
Yeah, we can call the next.
Hello, sir.
Are you there?
Yes.
Yes,
Fatima.
sir.
Yes.
Due to some technical errors, I got out of the meeting.
Okay.
Can I
Okay,
continue?
continue and finish fast.
Yes, sir. Just 2 minutes. Uh, so the random forest technique is employed, and next is the clustering techniques. Clustering techniques plays a significant role in the understanding of the customer
Hello.
satisfaction.
Hello,
By
Fatima. Have you
yes,
Screen,
sir.
shared your
screen
screen?
not shared.
Have you shared your screen?
Okay, sir.
Yeah, please share it, please.
Yeah. The clustering techniques plays a significant role in understanding the customer satisfaction by grouping the similar customer together based on certain characteristics and behavior patterns. These are the ways we have used the customer satisfaction in clustering, which is nothing but the segmentation, improving customer experience, customer journey mapping, and algorithm selection. So these are the results we have arrived at. So the random forest technique predicted that students uh, have have preferred Zudio more than any kind of people, and they were introduced to the store by their friends. Customers with a monthly income ranging from 5,000 to 10,000 were more attracted towards the store and was more satisfied with the brand services. Clothes, footwear, cosmetics, accessories was the most bought item at the Zudio store. Unique collection, brand, quality, and affordable price, wide range of size were the prominent features that are attracted customers towards the store. Uh, Further, 89% customers have rated the store have given the rating between 4 to 5 on the Likert scale. So with the application of K-means clustering, we have grouped their age and the brands based on the product quality, price range, availability, and the range of variety. K-means analysis can be further used to uh, provide any improvements in the store. So these are the two figures, and we have concluded that nowadays we are in the situation that online shopping to make our shopping easy while shopping in the online websites. No one hesitates to do that, and it's really tough for an offline store to retain their customers. So our study included all the necessary parameters and concluded that the students are the people between the age group 18 to 30 want to spend more time with their friends and prefer Zudio showrooms in the Zudio store situated in the malls. Thank you, sir.
Yes. Hello, Fatima.
Yes, sir.
Yeah. So, which clustering algorithm you have used?
Yes, sir.
Which clustering algorithm you have used to implement?
K means clustering algorithm we have used, sir.
K-means, okay.
Yeah.
And can you tell me how many classes were there?
Sorry, sir.
How many classifications were there? Classes in your clusters? How many clusters were
One
there?
second, sir. Uh, Sir, the people were grouped based on their age and the branch based on the product quality, price range, availability, and range of variety, sir.
Yes. Okay. So total, how many clusters were there?
Totally
Classes.
one, totally
One,
four,
two,
sir.
three, four, some four. So
Yeah.
how did you came to know those four classes are there? So how did you found how many clusters are to be formed? What did you use to do that?
Sir, we have grouped them based on their age, sir, and we arrived at this conclusion.
Yeah, but there may be some technique na, by which we understand how many clusters are going to be there. So
We
have you
arrived
heard
at.
about the elbow method? Have you heard
Can
about
you?
elbow method?
No, sir.
Yeah, yeah. So we have to use that elbow method in the clusters, to identify how many clusters are going to be there. So simple that we have to use. Okay. Fine.
Okay.
And have you done any comparisons with another algorithms?
No, sir. No, I haven't.
Yeah, yeah. So you must do that. Then we can understand which is the better one and which we have to use, right?
Okay, okay, sir.
Yes, fine. That's it from my side. Thank you.
Thank you.
Any questions from questions from delegates? If there are no questions, we can move to the next delegate. Next
Yes.
paper. I think
Next is Bharti.
101 Bharati. Yes, sir. Yes.
Yes, sir.
101 Bharati is ready. Bharati, yes.
Yes, sir.
Yeah, please share your screen.
Wait.
You can keep the phone horizontal so that it will look better. Visibility will be more. Just turn the phone horizontally.
It is not coming from.
Auto rotate. Auto rotate. If you do, it'll go.
The auto rotating mode is not there, sir.
It is not there.
Sir.
Okay. Okay. No issue. No issue. Go ahead. Go ahead.
So myself, yes, Bharati, sir. Vistas, Chennai. My guide, Mrs. Dr. P. Sujata. My research paper is Traditional Energy Efficiency Improvement Method in Oil and Gas Industry using Hybrid Machine Learning Approach. These are all the contents which I am going to explain. Abstract. In the oil and gas industry, there are multiple opportunities to reduce total production energy consumption to produce the equivalent or more unrefined petroleum and flammable gas. Our work focused on predicting the energy utilization of OGA. First, four different prediction models: support vector machine, linear regression, extreme learning machine, and artificial neural networks are prepared. The second is to work on the precision of energy utilization expectation. The combination of these four models was tested. The results show the four different model predetermines energy consumption versus accuracy as well as hybrid and model of red neuron for maximum accuracy. Objectives: energy consumption forecast for oil and gas organization are conducted all the corporate level rather than the oil operation level, which has proven useful for company managers and policymakers to come to informed conclusion about energy use. Four different forecasting methods and 6 hybrid models for enterprise energy consumption forecasting are discussed and analyzed. 4 types of performance evaluation indicators are talked about to access the forecast model. The lower the model indicator esteems, the better the model exhibition. The after effect of this paper can be used to expect the energy utilization of other oil and gas organizations. Traditional energy efficiency improvement methods. The oil and gas industry sector, there are multiple opportunities to reduce total production energy consumption and improvement in efficiency that can be impacted by mechanical, synthetic, and other actual boundaries. The least square SVN model is used to anticipate to incorporate energy consumption from oil production operation in some areas. Operational cost will be significantly reduced due to faster, improved decision making. This work studies the energy utilization forecast strategy of data driven federate machine learning model to simply improve energy efficiency and apply faster model performance to actual production at the enterprise scale rather than at oil operating station atmosphere. Proposed models, the objective of the primary stage is to partition the whole information index into few unique subsets of or gatherings considered as a grouping strategy. The second stage predict energy consumption with two-dimensional contribution of unrefined petroleum and flammable gas creation in every information subset. The final stage aimed to enforce the last forecast result through the group model. The conclusion is that ensemble model can improve the speculation capacity and existence of AI model compared with single model. Methodology datasets. In this article, we collect 2-decade energy creation and utilization information for 4 oil and gas companies. Typically, in oil and gas companies, this data will be announced by the energy executives framework. So the assortment recurrence is month to month. We gather 12 perceptions each year, and the data set contains a total of 960 information test methodology prediction matrix. To access the precedence force of this model, measurements are presented. First of all, forecasting minimum error, which can be straightforward all sum of I vi minus vi the whole square. Methodology clustering. As a centroid base bunching strategy, K-mean predominantly follows 2 steps iterative calculation. First, assign each observation to its closest subset and then adjust the mean to minimize the distance of the total sum of square within the group, and the process is repeated until the medium remains stationary. Methodology, hybrid model forecasting result. Numerous energy utilization expectation issues have all the earmarks of being exclusively interest for a solitary AI model. So we tested a hybrid approach to explore prediction accuracy. Often, hybrid model can compensate for the shortcoming of individual model and provide better performance. To reduce computational consumption, we simply the most delicate and usually utilized measurement, namely RMSE, was chosen instead of 4 measurement to access the exhibitions. Experimental results, methods used SVN, LR, ELM, ANN plus ELM hybrid, root mean square error, mean absolute error, mean absolute percentage errors are shown in this tabular. The visualization of the above tabular graph is shown over here. Conclusion, experimental results shows that a large portion of 4 dissected model can show good energy consumption, prediction performance, and the coefficient of determination of this model in all the dataset ranges from 0.70 to 0.95. Among them, the half-breed model of ANN and ELM show the best exhibition and was picked out as our last model for predicting the all-out energy utilization of oil and gas fields. We have likewise introduced this model in the energy, the board course of action of the oil and gas industry to assist organization with anticipating absolute energy utilization and further develop energy effectiveness. These are the 10 references which I took. Sir? Hello? Sir?
Yes, yes, yes. Please go ahead.
Sir, conclusion over,
Hello.
sir. Conclusion over,
Yeah,
sir.
yeah. So you have finished?
Yes, sir.
Okay. Yes. So, yes, I want to
So,
ask you. So you also have used for the clustering K-means only, right?
yes, sir.
Algorithm.
Yes, sir.
Yeah. So do you know any another algorithms that can be used for clustering?
Um, in this, sir, we are
If
utilized ANN and ELNN, sir. ELM.
okay, ELM.
ELM, sir.
So yeah. So do you think then it is working efficiently with K-means only? Do you mean like that? This
Yes, sir.
method?
Yes, sir.
Okay. Okay. So we know that K-means is distance based, you know.
Yes, sir.
So how the two distance is being calculated in between two sample points? Can you tell me?
Two sample points, sir. Um,
Yes.
starting
So what
to
is that
end
formula?
formula, sir.
Yes. What is?
One,
Yes.
1 minute,
Yes.
sir. Sum of I, Vi starting, Vi minus Vi the whole square.
Okay. So something it is. You mean y2 minus y1, x2 minus x1?
Yes, sir.
Okay. Any another performance metrics?
Matrix, 1 minute, sir.
Okay. You used root mean squared, right?
Yes, sir. Root mean
Error
square.
loss function.
Error, root mean
Yes.
square
So
error. And also
yes.
MAE, mean absolute
Yeah.
error, mean absolute error,
Okay.
percentage error.
So why? Oh, okay. Why? So why you used those only? Are there any others? What was the problem with them?
Sir, I took this only, sir.
Okay. So just yeah, comparative study you need to do, right?
Okay, sir.
Yes.
Okay, sir.
Yes. Yes. Thank you. Thank you
Okay,
from
sir.
my side, sir.
Okay, sir.
Yes.
Okay, thank you, sir.
Yes. I
Hello.
think Susmita. Yes, Susmita. Susmita.
Hello, sir.
Yes.
Hello.
I'm audible, sir.
Yes. Yes.
Oh, good afternoon, sir.
Yes.
Good afternoon. Go ahead, please.
Please share your screen.
Good afternoon, sir. Myself Sushmita,
Yeah.
Assistant Professor, Department of Mathematics, Ballari Institute of Technology Management, Ballari, Karnataka, India. Today's my topic is coem polynomial and topological coincidence of anti-consider. Mainly my presentations consist abstracts, introduction, preliminaries, results and discussions, conclusion and references. Cancer is the leading cause of death worldwide. Accordingly, for nearly 10 millions of deaths in 2020, or nearly 1 in 6 deaths. The most common cancers are breast, lung, colon cancer, and more. Around one third of deaths from cancer are due to tobacco use, high body mass index, alcohol consumption, low fruit and vegetable intake, and lack of physical activity. In this present work, we continue our investigation of anti-cancer drugs and define coem polynomial by considering equivalent contributions from a pair of non-adjacent vertices which capture and quantify the potential influence of distinct pairs of vertices on the molecular attributes. The true strength of polynomial is the compressiveness, which includes useful information on degree-based invariance, many degree-based topological coincidence that link chemical features of the material under research produced in closed form by the polynomial using elementary calculus. In the present era, technological development and chemical pharmaceutical technique recent years have been rapidly evolved, and thus large number of new nanomaterial, crystal materials, and drugs emerge in every year. To determine chemical properties, such a large number of new compounds and new drugs require large amount of chemical experiment, thereby greatly increase workload of chemical pharmaceutical research. Fortunately, the chemical-based experiments found that there was strong connection between topological molecular structure and physical behavior, chemical characteristics, and biological features such as melting point, boiling point, and toxicity of drugs. Topological index is a graph invariant which characterizes as topology of molecular structure and convert molecular graph in a real number that predict physiochemical properties such as freezing point, melting point, boiling point, and nowadays, biological testing of chemical compounds is too much expensive. It requires a large laboratory and advanced equipment to test these compounds. This process is costly and time consuming. Due to this factor, pharmaceutical companies are very eager to find such new ideas or methods by which could reduced. One can reduce the cost, which no need of laboratories and no need of equipment, but just need study the certain chemical structure using topological indices. This is a one molecular structure we are converting into molecular graph. Research have been developed degree-based topological indices quantify contribution of adjacent vertex pair. However, recent efforts have also considered non-adjacent vertex pairing, leading to the development of degree-based topological coincidence. To enhance understanding the molecular characteristic, researchers have formalized the first and second Zabra coincidences of graph. Considering the importance of polynomials based on non-adjacent vertex pairs in computing graph coincidences, there is a growing interest developing such polynomials further investigate the properties of chemical compounds. In our present work, we have used coindexes. These are the formula and notation we are used coindexes. Also, we extend this concept for M polynomial adjacent pairs of vertices. This is the formula for coem polynomial of polynomial. Using also we used the lemma. For connected graph G order n, we have two types of it. Suppose I equal to j, then ni into ni minus 1 divided by 2. Then if I is less than j means ni into nj minus mij. Mij means n1 and ni and nj are number of vertices. Mij means number of edges in a graph. These are the definition of topological indices we are used in our work. This is the formula for M polynomial of coindex. In our present work, we have several anti-cancer drugs are used. Around 16-17 anti-cancer drugs are used. From this, we obtain the result that the co-M polynomial of ampersand is one of the anti-cancer drugs is obtained by 41xy square plus 43xy cube plus 51x square y cube plus 18x square y square plus 5x square y4 plus 22x cube y cube plus 6x cube y4. Here, this is the graph. Mainly consists total number of vertices is 22 and total number of edges is 24. By using the edge partition method and definition of co-M polynomial, we have obtained these results polynomial, and this table is edge partitions of above molecular graph. This is the by mathematical simplification, mainly M polynomial definition and number of edge partitions, we obtain this result. From the M polynomial, we obtain some molecular graph of some topological indices. First, we obtain first Zagreb index, second Zagreb index, and modified Zagreb index, redefined Zagreb index, and SDD index, augmented Zagreb index, F index, and harmonic index. Similarly, we have selected one more molecular graph, molecular anti-cancer graph. This is the amino protein. This equation is co-M polynomial of above molecular structure. Similarly, here also we obtain total number of edges is 34 and total number of vertices is 28. This is the edge part. This is the table is the edge partition of the graph. Same here, using M polynomial definitions and edge partitions, we obtain these results. This is the sum of the anti-cancer drugs and their topological indices. M1 first diagram, second Zagreb, and modified Zagreb, and redefined and F index. These are the comparison tables of some molecular drugs. The co-M polynomial as described in this work is capable of creating closed form of large number of degree-based topological co-indices that correlate chemical properties and substance under investigation. As a result, in the study, we examine a variety of anti-cancer drugs and analyze their structure to determine the co-M polynomial for this treatment. Then these polynomials are also used to generate a number of degree-based topological indices. Hello? Hello?
Yes, proceed.
Hello?
Yes, continue audible.
Yes, Susmita. So you have done this for all the polynomial, right? So nothing is to do with non-polynomial?
Which polynomial, sir?
Non-polynomial.
No, sir. We have only polynomial we applied.
Yeah, okay.
M polynomial.
Only for the polynomial you are working. Okay.
Yes.
Yes. Presentation, yes. Good aspects, all mathematically explained. Yes, thank you.
Okay, sir. Thank you, sir.
Yes. Thank you. Yes, I think next is William. Are you there?
Yes, sir, I'm here. Let me share my screen.
Yeah. Please do fast.
Yes, sure. Am I visible, sir?
Yes.
Yeah.
Good afternoon, everyone. Myself, William Mary, and my guide is Dr. S. Albert Anthony Raj. We are from SRM Institute of Science and Technology, Katanguludu, Department of Computer Science and Applications. The title of the paper which we are going to present now is Wearable Technology for Monitoring and Assessing COVID-19 Using Machine Learning Algorithm. It is a survey paper. It is not containing any result-oriented. So these are the agenda points which we are going to discuss in this presentation. Introduction, history of wearable technology, wearables designed for on-body positioning, methodology and various architecture, and finally conclusion. In the introduction, wearable technology consists of small electronic devices which are also consisting sensors. That sensors collects the heart rate monitors and pulse oximeters, temperature sensors, which can be used for the collecting of the real-time data. And also this particular sensors and this particular wearable technology could be helpful for monitoring the COVID-19 disease in the patients. So this is the history of wearable technology, where the wearable technology started in the year of 1960-61.
Slide is not moving. Slide is not moving.
1 second.
Okay.
So this is the history of wearable technology in the various years, how the wearable technology could be implemented. In the 1960-61, tiny 4-button computer which was started, and end of the wearable technology relies on 2020 in the gaming industry, like AR and VR technology, which considering headsets. In the future, wearable technology is completely going to be AI in the artificial intelligence, which is integrated with the human brain. So this is the wearables designed for on-body positioning. What are the wearables? Means headbands, sociometric badges, camera clips, smartwatches, sensors embedded in clothing. So these are the various wearables which can be positioning on human body, and which will be helpful to collect the data based on the various research-oriented topics. So methodology, generally in the machine learning mechanisms, the wearable technologies could be used for data extraction, preparation, model training, testing, and finally comparison. So how the data could be collected? The data could be collected for the research work. Most of them have been collected through the open source platform of the wearable devices like smartwatches, fitness trackers. So this collected attributes are heart rate, breathing rate, body temperature, oxygen saturation. This is for the COVID-19 cases. COVID-19 researchers, various artists have been collected the open source data, and also this wearable devices detects the signs of COVID-19 symptoms also, which will be more helpful for the researchers. And also heart rate variability and pulse rate variability should be incorporated in this study. So algorithms, the basic algorithms, initially they will be many artists used so many types of IoT sensors, and then they will be using machine learning algorithms for the predictions, for training data set, testing data set, and comparison. And also one of the most mainly used algorithm is fast Fourier transform algorithm, which is the signal processing algorithm. So this could be used in the wearable devices to capture the information from the human body and transferring those information through the signal process as a data. So this is the architecture, how the data could be extracted from the human body through these psychological characteristics or symptoms which can be reported. Once the data could be extracted, they will be going for the data preparation. In the data preparation, they'll be following some sort of methods like data cleaning, feature selection, feature extraction. finally data augmentation and the data labeling. So data splitting, these are the methodology could be helpful for the data preparation. After the data could be prepared, they'll be going into the model training and testing. When we go for the model training and testing, we'll be splitting the data as per the ratio. For training, they'll be splitting the data as 70 to 80 percentage, and testing it is about 30 to 20 percentage. In the training set, they'll be doing two sort of work. One is training the model and then validating the model. In the testing part, only they'll be testing the model with having the 20 percentage or 30 percentage of data. So this is how the basic preparation will be happening. The next part is model comparison. So the model could be compared with the existing model. So in the COVID-19 diagnosis, the newly developed model will be compared with the existing model based on the symptoms or what sort of research materials, research metrics they have been considered. After that, the model will be selected. So after comparing, the best model will be bring out, and then the external validation could be done. The final step is model deployment. This is how the initial to the ending, the model evaluation and model deployment will be carried out. So conclusion part, wearable technologies which holds the promising addressing infectious disease like novel coronaviruses, and also this wearable devices also monitors fitness of the COVID patients, and which will be indicating that these patients are having the infections or these patients are not having the infections. So this will be more helpful. But based on this, we are going to implement our device. That's all, sir.
Yes. Okay. Yes, William, how many papers survey you have done?
We have been taken more than 50 for this particular analysis, sir. But before that, we have been done so many COVID analysis. Those analysis have been taken for a basic machine learning prediction. For this wearable technology, we have just started and going through more than 50 papers.
Okay. And what did you found the most gap in all those papers? Can you tell at least two?
I don't get your question, sir.
Gap in the existing system. What did you found the gap so that it will motivate you to come onto your problem statement
Yes, sir.
for
Yes, sir.
future?
Actually, the thing is, to be frankly said, I didn't find any full-fledged solution in the existing papers because no idea why they didn't provide the exact solutions. And also, once after developing the wearable technologies, they didn't go for any installation, and also they didn't collect the data properly in the live data. I mean, real-time data set. So, like this, there are so many gaps, and also the frequency of measuring the data, that also one of the drawback, and also some kind of limitations they have been followed. It should be there in the research, but the thing is most of the research article could be considered we had 90 percentage of accuracy, 95 percentage of accuracy, but nowhere it is there the real-time applications.
Okay, so all these gaps then you're trying to bridge in your problem statement,
Yes,
right?
sir. Yes, sir.
Yes. Okay, fine. All the best. Thank you.
Thank you, sir.
Thank you. Thank you. Yeah, the next delegate is ready.
That's all, sir.
That's all, huh?
Yes, sir.
Okay. Thank you, Dr. Anand, for your excellent interactive chairing of the session.
Yes, thank you, sir. Thank you so much.
Thank you very much. Thank you very much.
Yes. So, what will be next agenda, sir?
Yeah, next agenda is our valediction, sir. Within
Yes.
a minute or so, we will be starting, sir.
Okay, so I have to stay in the meet, right?
If you are available, you can stay, sir, or else you can leave, sir.
Yes.
Thank you very much, sir.
Okay.
Thank you, sir.
Yes. Thank you. Thank you so much.
Thank you very much.
Thank you, Professor. Thank you, Professor.
நான் அறுக்கிறது
Balamurugan, sir.
Yes, sir. Yes, sir.
We can keep talking and send those abstract numbers.
Sir, yes, sir. Yes, sir.
அனுப்புங்க.
I already sent, sir.
Okay, sir. Okay.
One right now sent, then another one already there, I think. Sir, 1 minute, sir.
Okay.
One I sent already. Then another one you are asking this. Sir, another one, I think 1 minute, sir. Hello, from audience, anyone, please give the feedback overall these 3 days. Hello, Harim sir is there? Harim? Karim sir?
Yes, sir. Yes, sir. 1 minute, please be wait.
Okay then.
I'm here only.
Yes sir. Please give one feedback, sir. Feedback from you, sir.
Feedback from my side. Okay. Happy to see you all. Very nice. The last 3 days, there are so many paper presentation and invited talks, series of talks. First of all, I congratulate to all the organizing team. They are well organized, well planned, the proper schedule. I think there are many different areas invited talk you invited. All are given the very good. From my point of view, I will not attend all, but due to my duty work, I will attend 1 or 2 only. But anyway, I will enjoy it. On behalf of all the participants, I have 2 requests to you. You may conduct this type of conferences maybe once in a year. And as well as you may try to conduct the MATLAB workshop in the after office hours. A few of my friends are asking frequently if better to conduct after office hour, mean they will be helpful. You may consider for my request, and congratulations to all the organizing team and participants and invited talk people. And thank you, Anandal. Thank you.
Yes, sir. Sir, we agree, sir. Thank you, sir. Thank you. Sir, any ladies participants? Sir, tell me, sir. Satya Pandey, sir. Satya Prakash Pandey, sir. Yes, sir.
Yes, sir. Yes, sir. First of all, I will try to. I want to congratulate to all organizers and all the participants here. So this is Satya Prakash Pandey from University of Mumbai. Sir, let me share my experience is that I found this platform is one of the wonderful and unique platform because the experts and the chair of the session all were very good and excellent, and all are I can say they are all doctors, and I just gone through their CV and all. They are having so many they are holding so many big positions in different universities and all. And especially in the case of mathematics, sir, in Mumbai, very few conferences were organized in the last year. So I was just searching the conference. Then I came to know from the Facebook only that this conference is going to organize so and so date. So I'm very thankful to the organizer of this international conference and all the dignitaries over here. So it was a very wonderful experience and very unique. I would also like to request the organizer that please try to organize such conferences at least 2 or twice or thrice in a year, so that for the researchers like us will get a chance to communicate with our community, and will try to come to know the updates in our research area. So thank you, sir. Thanks a lot.
Thank you, sir. Thank you, sir. Wonderful suggestion, sir. Any other? Please give me your feedback. Anyone, ladies, please. Anyone? Here, lot of people are there.
Okay, sir.
Okay.
Good. So,
thank you, Madam Muthuselvi. Thank you, Madam.
Yeah.
Really, this conference is useful for.
Yeah, we are very happy to have such a feedback. Definitely, one of the participants told kindly conduct a workshop. Even the first day, the chief guest of our conference told you conduct workshops. It is not enough if you conduct only conferences. So in that way, we have already started MATLAB workshop. In the month of November, we conducted 7 days workshop. We conducted. So in the similar way, in the from after the conference is over, also the workshops will be conducted alternatively. After the conference, definitely some very useful workshops will be organized by New Research and Innovation Society. And,
sir, excuse me, that workshop should be after office hours, please.
Sir, we conducted, for your kind information, we conducted the workshop only after office hours, that too between, I think, 7 and 9. Am I right, sir?
Very good. Yes.
Sir, 8 to 9.
Yeah, 8 to 9. Sorry, sir. 8
very
to
nice,
9.
Very nice. Very nice.
Conducted 8 to 9. 1 hour per day, and all the 7 days it went on very, very effectively. And we have posted all the proceedings in our website also. You can
materials, all materials.
It is available in the website. The proceedings is available. Materials also is available. Thank you for your suggestion, sir, Professor Fajlul Karim. And also you have graced our occasion by delivering a wonderful talk, and it was really very nice. And I am very happy to see you in the valediction also. So this is the time for finalizing the today's program. Before announcement of the best paper presentation award, so though all participations were very, very active and very, very sincere, we could say, we have selected only 6 participants for best paper presentation award. So at the end of this program, we will announce those 6 abstract numbers, and the cash awards will reach them by today itself, and the certificates also will be delivered to them subsequently. And before that, we welcome the awardees. We have a short function of award ceremony for 2023 and 2024. The awards are presented by New Rains, Chennai, India, to 14 awardees. 16 awards are going to be presented. So we welcome the awardees. Even some of the delegates also receive awards. I think Satya Prakash is there, and Adinath Upadhyaya, who is also a participant in this event. These 2 are receiving the awards, and like that, totally 16 awards are being presented. I now request Balaji to share the award presentation. Balaji?
Yes, sir. Yes, sir.
Please. Thank you, Balaji.
Thank you, sir.
Thank you. Thank you very much. I congratulate all the awardees. I think we can call one or two awardees to say a few words. Mr. Dr. Debashis Mandal. Sir, you want to say a few words? Abhijit Das. Sir,
Debashis Mandal. Thank you, sir.
Yeah, yes,
Thank
sir.
you,
Yes, sir. You want to say a few words, sir?
It's good to get the award. Thanks.
Yes, sir.
For your consideration.
Thank you, sir. Thank you, sir. Congratulations. You deserve the award, sir. Thank you, sir. Thank you.
Thank you.
Abhijit Das. Okay. Satyaprakash.
Yes, sir.
Yeah.
Congratulations for
congratulations.
Thanks to all the organizing team. Sir, let me share one thing is that such type of ceremony or award will motivate us, sir, in future to do the more and more research. Not only us, sir, but many more young researchers. It will motivate them also to do the lots of research. And sir, right from 2015, I started my research journey by writing the first paper in the field of applied mathematics.
Okay.
So I wrote maximum paper in the applied. The thing is that my guide always says that you try to, whatever you are doing, try to find out the application of the thing. So I wrote maximum papers in applied mathematics. And today I am very happy, sir, that this platform gave me this opportunity to have this best young researcher award. Thank you. Thanks a lot, sir.
Yeah. Thank you. Thank you. Congratulations. Yeah. Any other awardee wants to talk? Okay. I once again congratulate all the awardees for their best performance in the year 2023. And New Rains has honored them. New Rains is proud to present these awards to them. So the award materials, memento, certificate, everything will reach them by post shortly. It is the time to declare the best paper presentation awards. See, I would like to say once again that all the papers were presented very well and very sincerely presented, but still due to lack of funds, we limit our number of awards to only 6. Even in the last conference, we awarded the best paper presentation awards to 6 participants, 6 papers. So in that way, I am declaring the details of the 6 best paper presentation awards. The awards go to the following 6 persons. Abstract number A054, Ms. Jancy John, Bharat Mata College, Kerala. Congratulations. Abstract number A007, Niveta Martin, Arulanandar College, Karumathur. Then Dr. Masani Ammal, Government College, Udumalpet. The abstract number is that is 134. Abstract number is 134. Then abstract number A029, Dr. Muthuselvi, SRM Institute of Science and Technology, Ramapuram. Then A030, Ms. Indumadi, Wales University. Then A008, Ms. Sasikala, AM Jain College. Congratulations to all of them. Thank you all for your active participation and your contribution. I wish you all the best, and I also wish you all a very, very happy New Year. Thank you, one and all. Professor Balamuralidharan.
Okay. Okay. This is our second international conference, COMAT 2023. First of all, I thank to our chief guest, VC, Savida University, Dr. S. Suresh Kumar, and our proceedings released by Dr. S. Nedinjalian, Dean School of Computing, Bharat Institute of Higher Education and Research. Then our foreign professor, innovative professor, all are has given a very good presentation. Good feedback also already we received. In our foreign professor, Ghana, Professor Ebenezer Ponniya, here due to some network issue, sir released the video and some doubts also clarified. He's a 2% scientist. Right now, he is in one of the 2% scientist in Ghana. The next another one partition and then another one innovative talk, ma'am. Topsy Nakbal is a very nice presentation on deep learning and applications. Then mathematics professor, it's highly very active person. Ismail Kangal, his resume has nearly exactly I received 151 pages. He published more papers. His knowledge was highly good. The number of graph, he is in graph theory. He's a very big researcher. Graph theory people kindly use this professor for any doubts and any further clarification. Then second day, our friend DK Singh has given the wonderful speech on incomplete fractional calculus. Sir from Kanpur, India. Another one friend, my friend, is a very wonderful topic. Mathematics of cancer is one of the mathematical modeling topic, very good topic. Dr. MG Fajrul Karim, sir from Oman. Sir also has given the wonderful application and mathematical modeling related speech is a very nice presentation. Then afternoon session, ma'am Sivani Gupta madam from VIT Chennai. Domain the computer science, wonderful talk given from computer science. Then today, third day, Silas Iyer has given a wonderful talk. You know that IoT and artificial intelligence, SAR has given a lot of real life application. It is wonderful and motivated. A lot of things are unknown. Many of the people unknown things, unknown ideas. Lot of things are given. It's a wonderful speech in the morning session, 10 to 10:45. Then, ma'am, another quantum algorithm. Tulasi madam from Amirda University has given another wonderful speech based on the drug discovery. Finally, the mathematics professor and get Savida University, Iranians are also given wonderful application from fluid dynamics and how to solve and how to some methods for numerical and analytical methods by solving nonlinear partial differential equation, everything clearly given with applications also given. So I thank to all innovative talk persons and chief guest and chairpersons, Vishwanathan sir, Dr. P.K. Kumar, Kumarnath sir, Balamurugan sir, Prashant Kumar Srivastava sir, Neelam sir, Anthony Xavier, M.D. Golam, Jain Sri madam, Lakshya Jyoti madam, Sri Lada madam, Sonam Mittal madam, Anand Nagesh, all participants, all chairperson, session chair, co-chair, I would like thanks again. Then our conference chair, special thanks to our conference chair, Dr. P. Kamrai sir, and our technical team person, Balaji, and his team, Balaji teams. All I thank. Thank you so much. Then again, I tell you thank you so much for all the participants. Thank you all.
Yeah, thank you, sir. Thank you, sir. Some participants have asked about the certificates. Kindly check your mailbox. We have part of the delegates might have received the participation certificates, but those participants who have submitted the presenting author details only should have received. For others, we could not process. Without knowing certain details, we could not send the certificate. Kindly understand us. So please, if those who have not submitted presenting of the details, you can do it now also, so that we can it will be helpful for us to process the certificate dispatch. So we have already sent part of the certificates to the delegates. You can check your mailbox. The people who have not submitted the presenting of the details will not get the certificates. That is possible only when they submit. For others, we are already in process, and part of them have already received the certificates. Thank you all. Thank you very much. Wish you all once again a very happy New Year 2024.
Yes, sir. Happy New Year to all. Very soon you will get a mail journals, is sir?
Yes.
Journal.
Regarding the publication of papers, we are working on it. Probably tonight we will be dispatching the list of journals with all required details. All delegates shall submit or should submit their full papers. We want to publish this time all the papers presented in this conference. We have received, there were 134 papers presented in this conference. We want to publish all the 134 papers. So both computer science and mathematics, we have enough number of journals, both Scopus and UGC CARE journals. So you please submit the papers. In that mail itself, you mention which journal you want to publish your paper. Okay, so that is very important. And once you select the journal, you please see that the paper is prepared in the template of the respective journal. You confirm these things, and then you submit the paper along with the other details. So, and always you mention your abstract number in the subject line. Mention your abstract number and the journal you want to, in which you want to publish the paper. These two things shall be in the subject column, so that it will be very easy for us. And also you mention full paper. Okay. For example, A001, Journal of Computer Science, full paper. That is enough. So if you do that, it is very easy for us to peer review the paper and submit to the journal. And some journals may require immediate payment. For example, UGC CARE journals. All other journals will accept the APC only after acceptance letter is issued to the authors. So you have to wait for the acceptance from the journals, including IEEE and all other journals. Okay. Thank you all. If you have any doubts, you can ask. Otherwise, we can close.
Sir?
Yes.
Sir,
madam.
this is Anisha, abstract number 056.
Okay.
Sir, I think I have already given that presentation that form which you have sent. No, I filled that too.
Okay.
You said that the certificate must have reached, but it's not yet come.
It is being sent. Part of the delegates we have already sent. You will be receiving shortly.
Okay, sir. And sir, the proceedings copy also.
Good. It is good that you reminded. Proceedings will be available. E-proceedings will be available in the website by tomorrow, and the hard copies will be sent to the participants who have paid for the hard copies shortly. we will inform.
Okay,
Thank you.
sir.
Thank you.
Yeah, sir. And one more doubt.
Yes.
So you said that the acceptance. Now, I'm from computer science.
Yes.
So the paper which I have presented, and I have also sent the full length paper also.
Yes.
I think last week itself I have sent it.
Okay.
So after the peer review only, we will be sending us the list, or how exactly, sir, the process will be happening? You can tell something about it.
If the peer review, see, if the paper is in order, that means it is in the template of the respective journal you want. Have you mentioned that journal name?
No, sir, I have not mentioned.
Okay.
I've just sent the full length paper.
Doesn't matter. It doesn't matter. We have already stored it. However, we will tonight, maybe in another 2 hours or so, we will release the list of journals along with the other details. Okay, how much is the APC and all these things, whether it is Scopus indexed or UGC CARE journal, whatever it is, all the journal related details you will get. You please, you can even take one day, no issue, and then finally decide which journal you want to publish your paper. Once you decide the journal, please don't change it, because once the paper is accepted by the respective journal and the paper is also presented, you have to pay. So otherwise there will be it will create friction between the journal and the organization. And also, once the paper is submitted for publication, please don't come with any request to withdraw the paper. That also the journals do not like, and they may even later ban the respective author. So these kind of things should not happen. So please, you search, Google search the journal, whether the journal is good, whether it has impact, whether it is Scopus indexed or not, whether it is UGC CARE in UGC CARE list or not. All these things you confirm, then you select the journal. You tell us this journal in which we want to publish. Also, you can see the time taken for publication. We cannot urge the journal. They will take their own time. The time duration also we will give along with the list of journals. How much time normally it will take. So you keep all these things in mind, then you submit the paper. Okay, those who submitted, okay, but you again resubmit name so that it will be good for us to process. So once peer review is over, we will submit. Once the paper is submitted, we will inform you that your paper is submitted to this journal. So after which we will not change it. The journal will say whether your paper is accepted or not accepted. So we will take care of, mostly we will take care of acceptance of the papers. Thank you.
Okay, sir. Thank you so much. And sir, one more thing. Actually, this your about New Rains and COMAT 2023, I came to know from my Wales University.
Yes, madam.
Sir, is there any other medium where I will come to know that when is the next
program
or presentation or what?
Yes, madam. You are in our WhatsApp group, madam.
Yes, sir. I have just joined with COMAT 2023.
Yeah. New Rains group. If you are there, definitely you will get all the information. And also you are invited to become our life member. If you become life member, we give 20% of discount in the registration fees. That is also there. And if the next conference will be mostly offline, and in that conference, selected participants, we are planning to give first in the beginning for 2 participants to give TADA also, first 2 participants, first offline conference. That is our 3rd international conference. 2 people we will give travel support. So like that you have a lot of benefits. And we are also going to launch New Rains publication. We are already in the process. You can submit your book manuscript or your book content for publication in our New Rains publications. So we are also going to publish books, and we are going to start it from January 2024 also. So all these details will be available to all our members, and all those who have already attended, they are in the WhatsApp group. Thank you, madam.
Thank you. Thank you, sir. Thank you so much.
Any more clarifications needed? So I once again thank you all for joining us, for spending your valuable Sunday time in this conference and also in the valedictory and the award ceremony. And I once again congratulate all the awardees.
Any other? Yeah, sir, one person raised the hand.
Yes, sir.
Yes, sir. Tell me, sir. Abdul.
Sir,
Abdul Rahman,
certificate. First author and second author, same certificate or separate? If only first author certificate.
Sir, certificates, participation certificates you are talking about?
Only first author.
Yeah, participation certificates will be sent to your email ID personally, provided you have submitted the presenting of the details. If you have already given presenting of the details, please check your mailbox. We are in the process. Around 50 people have already received. So if not received, you can wait for a few hours.
Sir, but right name, first author and second author, only first author.
I'm not getting, sir.
Right name in certificate. First author and second author, only first author.
Sir, if you have any, if you have anything to say about the certificate content, please submit to. Have you submitted presenting of the detail?
Yeah.
Whatever you have mentioned in the presenting of the details, only we will give it in print in the certificate. Nothing else. We will not change anything.
Okay, sir.
If you have correctly given in the presenting of the detail, we will use it. No issue, sir. Thank you.
Okay, sir.
So if there are no more things, I once again thank you all for your time and your contribution. Thank you very much.
Okay, thank you all.
Thank you, sir. Wish you all Happy New Year.
Thank you.
Thank you.
Happy New Year.
Happy New Year.
Thank you, sir.
Bye-bye.
Thank you. Happy New Year.
Thank you, sir. Anand, sir.
Thank you, sir. Dr. Anand,
Yes.
thank you very much. Thank you very much.
Yes, sir. Thank you so much.
Wish you Happy New Year, sir. Professor, shall we close?